James Kaufman, World News Report today. Ladies and gentlemen, we're in a geomagnetic storm that was not forecasted. I am going to be able to explain this to you and what's going on. We also just got hit by the strongest solar flare that we've been hit with for about 2 weeks. So let's go into what's going on. As you can see from our different KP indexes, we started the day in a disturbance on most of the indexes. We've worked our way into a geomagnetic storm here on the estimated planetary index. NOAA's and NASA's go-to KP index has been upgraded and updated. Now, we do on the college index, which is elevated. By elevated, I mean higher in altitude. We see that it actually measured a G2 geomagnetic storm and then a G3 geomagnetic storm for a total of 9 hours of a geomagnetic storm. We're only seeing 3 hours, the latest 3 hours on our estimated planetary. No geomagnetic storm on our Fredericksburg KP index. We see 6 hours of a geomagnetic disturbance. Finally, on our Boulder KP index, we see that we are in a G1 geomagnetic storm, and we started out prior to that with 6 hours of a geomagnetic disturbance. Now we're going to go to the estimated planetary index for our information. I want y'all to remember this right here, because this is going to show up in the data. It's a geomagnetic disturbance. So all in all, 9 hours of a geomagnetic disturbance already today with a G1 geomagnetic storm. Although the college index is indicating a much stronger situation. What I like to do is go all the way around the world to Germany and look at their KP index so we can get an idea of what's going on there and compare the two. It looks like they might have been hit a little sooner than we were. All right, I did indicate we just got hit by the strongest solar flare that we've been hit with for over 12 days, and that's only a 1.33. Love the numbers. As y'all know, yesterday we got hit by 1.02, and 2 days ago, on Friday, we were hit with a 1.01 solar flare. So we've had some very, very light M flares, but because our shields are down, we're now experiencing the effects of this M1 solar flare. Believe it or not. And I'm going to show you how we know that that's what's going on. All right, the strongest in 72 hours and 24 hours has not been assigned yet. I'm going to say it's from 4316. And y'all know I've done the work on it already. That's the strongest flare in about 12 days. Now, it's again not been assigned to a sunspot region yet, and it peaked at 1823 UTC time. I was able to correspond that with a flash coming from a very small sunspot, 4316. Please notice that all the sunspots producing these flares are all simple in green. We only had a 1% chance of an X-class solar flare today, only a 20% chance of an M-class solar flare, and that ship did sail, and only an 85% chance of a C-class solar flare? Awful strange numbers there, in my opinion. Over to SDO, HMI intensogram, we see that we have a total of 5 Earth-facing sunspot groups, and most of them, all of them, are simple, although a few of them are becoming more complex. 4315 was giving us most of the trouble. The first 2 M flares were both created by AR 4315. However, the strongest M flare, the one that we've just had at 1823 UTC time, about 123 it peaked here centrally, So about 20 minutes ago, it looks like it came from 4316, and yes, I'm going to prove it. Over to GOES 19 Solar Ultraviolet Imager, 195 angstroms. Well, I brought it to the exact time of the peak. You'll be able to see this star light up right here. Now, it looks like we have all of these sunspots that seem to be flaring at the same time. But I'm afraid that that star that you see right there is going to be the M1.33 flare. And there you can see it right there. What I did is I matched up the exact impact time with that to find out where that flare was coming from, because the other two sunspot groups also seem to be having sympathetic solar flares, or at least a lot of activity. You can see what's coming around the limb here. Some very active sunspots. Down here, I've actually brought this to 1823, 1824. So y'all can see that little star peak right there. Pretty hard to see unless we knew exactly what time it occurred at. Let's not forget this coronal hole that was directly Earth facing and still is. And it seems to be growing quite a bit here. I will show it to y'all in a different filter so y'all can see how big it really is. But y'all must be able to see that little bitty flash there is the M1.33 solar flare. Alright, I'm going to jump over to SDO and show you what the sun looks like right now. And this is at 212 angstroms, so we can see what's occurred with this coronal hole. This could be a extended storm supposed to hit on the 24th, although we're in a geomagnetic storm now, and now they're predicting one for tomorrow and the next day, I believe. So this could in fact be 3 or 4 days of geomagnetic storms. Please take pictures of any aurora borealis that you might see and send them to worldnewsreporttoday@gmail.com. That's worldnewsreporttoday, 2 T's, @gmail.com, and we'd be happy to show them to the public. Again, this is the region 4316 that just created the M flare. This is 4315. It's the region giving us all the trouble lately. And these are the new sunspot groups coming around the limb that look oh so active that we're going to have to deal with for at least the next 12 days. Alright, here is our NOAA KP index breakdown, at least the forecast of it, from December 21st through December 23rd. You can see today nothing was supposed to occur. Well, they didn't realize that that first M flare was going to impact. Now, tomorrow they're looking for an impact about midday. That's from the second M flare. It's a little bit more Earth-facing. Same sunspot group as the first M flare that hit today, AR 4315. And on the 23rd, well, I guess they're already looking at this flare that just popped off, or they're anticipating the coronal hole wind stream to get here a little bit earlier than they had yesterday. Yesterday they forecast it for the 24th. I thought that that was a little bit out there, and I just don't think that they would have time to have updated this for that M flare that we just had. So it could be a double whammy on the 23rd. The whammy from the completely Earth-facing M1.33 solar flare we saw today, along with the solar wind stream from the huge coronal hole that should last a lot longer than 9 hours. Now that it's developed, it could last 24 plus hours. Alright, let's take a look at exactly what's happening. Our shields are up at some times or points and down at others. But when the red line goes below the 0 line, our shields are down. When it goes above it, they're up. So they're up and down, based on the space weather hitting the shields. They come up to try to protect us when it does in fact impact. Now, the problem we have here is our shields are, well, tilted south. And we discussed that anytime they're tilted south, even a minor incident can cause a geomagnetic storm. And that's what we're seeing here. So it looks like we have been impacted by that coronal hole, and this is going to be the start of the impact. How do we know? Because it pushed the solar winds in front of it all the way from 395 up to 709 kilometers per second, and there's no way that the winds from the coronal hole would have reached us already. So this must in fact be the plasma that's hitting now. You'll see some marks at 24 here, another mark at, let's see if I can grab it, 23.95 here, and there's a higher mark I'm just not going to probably be able to grab up here. But this is just the beginning of the plasma here, all of this. And what it did is it pushed the solar winds that were in front of it up to over 700 kilometers per second, which is impressive. And it pushed the temperature up, and we're seeing the plasma from that M1.01 flare 3 days ago impact right now. And I think that this will go on for just a bit longer, and we'll see some additional readings in the 20s and teens as far as plasma. Believe it or not, that CME lifted these winds and must have pushed them ahead of the CME and increased them when they hit Discover. Discover is our real-time space weather satellite. It orbits 1 million miles above Earth at what's called Lagrange Point 1. It has a sister satellite, the original space weather satellite. It's called ACE. It also orbits at Lagrange Point 1, 1 million miles above Earth. We usually have about 50 minutes between seeing it on our satellites and the impact itself. Now remember, mainstream science tells us our sun is 93 million miles from Earth, or 1 astronomical unit. And this is 1 million miles, so 1/93rd of that. Sometimes the space weather gets to Earth a lot quicker after it hits these satellites than 50 minutes, but I'm guessing about 50 minutes today. Now, this is how I found out when the impact was. I used our D region absorption prediction center. D region's the lowest region of our atmosphere, closest to the ground. We have the E and then the F, the E1 and E2 and F1 and F2 above that. And this is the D region, showing you X-rays hitting almost the ground level here, if not the ground level. And we're seeing, well, a small bit of radio alternation here. So they probably had some equipment problem in this small area here. Not a very powerful impact, but we got 1826 out of this, 1823 to 1826, which is how we determined when the flare popped off and how we found it on our solar ultraviolet imager. So just a little info on how I did that. God bless you guys. Please give us a thumbs up. Please share our video if you can. And please always remember, anything's possible. Bizarro world. Guys, take a look at our merchandise, brand new merchandise. I think you'll love it. And please support the channel in any way you can. God bless.